Good afternoon, everyone. Just wanted to make a real quick video on something I stumbled across. This is an Adam Sandler movie called I Now Pronounce You Chuck and Larry. And what I want you guys to do is watch carefully at the intro of this movie. Okay, now just in case you missed that, I'm going to slow this down for you and explain it really simple. Okay, first we have the famous indoctrinated logo of Universal Studios, which is a globe in space. Now as it disappears, watch what it turns into. Water. Now as the camera pans backwards, what you're going to see is the seasons change. Okay, here's autumn. Here's winter. Spring. And then summer. And then, of course, we have all of this taking place under a glass dome. So I just wanted you guys to see how they indoctrinate you and mock you with the truth at the same time. Thanks for watching, and God bless. Good evening, everyone. I thought I'd make a really quick, simple video on rainbows. Now, a lot of you, your whole life, have always wondered why that rainbow is in the shape of a dome. Why is it always arched? Okay, what I'm going to be showing you in this video is how that rainbow is formed, what causes that rainbow, and also at the same time, what causes the double rainbow above it. And it's really simple. Now, science will tell you that a rainbow is caused by sunlight and atmospheric conditions. Light enters a water droplet, slowing down and bending as it goes from air to denser water. The light reflects off the inside of the droplet, separating into its component wavelengths or colors. When light exits the droplet, it makes a rainbow. Okay, now for the most part, that's true, but what they're not telling you is that the raindrops are only there to work as a screen to capture what's being projected, okay? Now, in order to understand this, you have to be able to understand what refraction is. Refraction, deflection from a straight path undergone by a light ray or energy wave and passing obliquely from one medium, such as air, into another, such as glass, in which its velocity is different. Now here's an example of refraction. The white light has to pass through a prism, which is usually a glass or a crystal or a mirror, and cause the colors to come out, which, as you can see here, I'll break it down for you. The prism would be a glass of some sort, and it has to hit that glass and refract, which will make the colors, as you can see here in the rainbow. Okay, now that you understand what refraction is, I'm going to show you how this rainbow is formed. Now, what you got to tell yourself is, and we all know this, we've never seen a straight rainbow. We've never seen a rainbow going up, down, or down to up, or left to right, or even diagonally. It's always in the shape of an arch, in the shape of a dome. So here's what you have to remember. The white light is reflecting through a prism, which has to be glass, something of a glass form. So whatever that sunlight is hitting, when you see that rainbow, it's the shape of the prism that it's hitting, which is the glass firmament, the glass dome. That's why it's shaped the way it is. Now, the rainbow is always there. You just can't never see it unless it rains. The raindrops act as a screen, like if you were projecting a movie. The movie could be playing through the projector all day, but if it doesn't have a screen to reflect off of, you can't see it. But what you have to realize is the rainbow is always there. But the only time you see it is when it rains, because the rain acts as the screen. Like right here, check this out. There's always a rainbow out here. Now, if I take this water hose and I turn it on a mist, that mist makes a screen of water across the air. And it shows the rainbow, the reflection. Notice even right here where I'm at, it's still shaped like a dome. It's rounded because that's the shape of the prism that the sun is reflecting off of to give us this rainbow. It's really, really simple, folks. And like I said, and it's in 3D also. You know, no matter which way you turn, that rainbow's always there as long as you got that mist of water to give you your screen. So, are you with me so far? And if you are, now I'm going to take you deeper into the rabbit hole. Now, you thought you were awake before? After I show you this, you're really going to be awake. Okay, here we have a rainbow over the ocean. Now, what I want you to pay attention to is the reflection of the rainbow over the water. Notice how the colors are inverted, which means reversed, backwards. Notice how the colors go backwards from the original rainbow on its reflection in the water. So we know in our simple common sense that that's a reflection of the rainbow, so it automatically reverses the colors. Just like if you and I looked in the mirror, the left side of our face would be the right side of our face, right? Okay, now that you understand that, look at the double rainbow. Look at the rainbow on the outside of the original rainbow. Notice how the colors are reversed, just like they were when you seen the rainbow over water. That's because the firmament is the glass prism showing the reflection of the original rainbow. That's why the colors are backwards. Now, as you can see here, I've made a rainbow of colors on a piece of paper, but I'm showing you how the colors invert, how they reverse when I hold it in front of a mirror. Therefore, proving, just like you've seen over water, when those colors are reversed, that's the reflection of the rainbow in the firmament above. Now, if we look up how to make a rainbow inside, here's what it tells us. We need a flashlight or a sunny day, a mirror at least 5 by 5, a pan of water, a CD, and a prism. We use this one, Kedco Light Crystal Prism 2.5. Now, here we go. I'm going to go through this really, really quick. We're going to fill the bowl of water. We're going to use the mirror. You have to remember that the mirror is flat. It's straight and flat. So therefore, our rainbow, which is going to reflect on the wall, which would be your raindrops, your mist, which will be your screen. Check this out. It's going to be a straight rainbow, a straight line, okay? Because it's a straight, flat mirror. Now check this out. If I take a round dome-shaped glass and let the sunlight shine through it, guess what I get? A rounded, arched, dome-shaped rainbow, just like you see every time it rains, because the rain drops give you a screen to see what's projecting from above. But even though I've made a double rainbow here, it's not inverted. The colors are not reversed because there's no reflection like you see here where the colors are reversed, because what you are looking at is a reflection of the rainbow in the glass firmament above, just like you see the reflection of the rainbow in the waters below it. It's just a reflection. And just like I showed you before, the rainbow is always there. You just need a screen to capture it, just like you always need a movie screen to capture what's being projected out of the projector, the movie that's being projected. It's always there, but you need a screen to capture it, like you see right here. So like I said, whenever you see that double rainbow, what they call a double rainbow, all you're looking at is a reflection of the rainbow, a mirrored image of the rainbow in the firmament above. God made the firmament to separate the waters below the firmament from the waters above the firmament. Everyone have a good night. Thanks for watching. and God bless.
In the flat Earth model, the sun and moon spotlights are perpetually hovering over and parallel to the surface of the Earth. From our vantage point, due to the law of perspective, the day and night luminaries appear to rise up the eastern horizon, curve peaking high overhead, and then sink below the western horizon. They do not escape to the underside of the flat Earth, as one might imagine, but rather rotate concentric clockwise circles around the circumference from tropic to tropic. The appearance of rising, peaking, and setting is due to the common law of perspective, where tall objects appear high overhead when nearby, but at a distance gradually lower towards the vanishing point. Samuel Rowbotham said, "Although the sun is at all times above and parallel to the Earth's surface, he appears to ascend the firmament from morning until noon, and to descend and sink below the horizon at evening. This arises from a simple and everywhere visible law of perspective. A flock of birds, when passing over a flat or marshy country, always appears to descend as it recedes, and if the flock is extensive, the first bird appears lower or nearer to the horizon than the last. The farthest light in a row of lamps appears the lowest, although each one has the same altitude. Bearing these phenomena in mind, it will easily be seen how the sun, although always parallel to the surface of the Earth, must appear to ascend when approaching and descend after leaving the meridian or noonday position. What can be more common than the observation that, standing at one end of a long row of lamp-posts, those nearest to us seem to be the highest, and those farthest away the lowest, whilst, as we move along towards the opposite end of the series, those which we approach seem to get higher, and those we are leaving behind appear to gradually become lower. It is an ordinary effect of perspective for an object to appear lower and lower as the observer goes farther and farther away from it. Let anyone try the experiment of looking at a lighthouse, church spire, monument, gas lamp, or other elevated object from a distance of only a few yards, and notice the angle at which it is observed. On going farther away, the angle under which it is seen will diminish, and the object will appear lower and lower as the distance of the observer increases, until, at a certain point, the line of sight to the object, and the apparently uprising surface of the Earth upon or over which it stands, will converge to the angle which constitutes the vanishing point, or the horizon, beyond which it will be invisible. Heliocentrists would have you believe the very opposite of what every human who has ever walked the Earth has seen with their own eyes. It is obvious to any child and sovereign-minded adult that the sun, moon, stars, and planets, every light in the sky above, revolves around the motionless earth beneath our feet. It is also plain to see that the sun and moon are both approximately the same size and situated relatively close to Earth, not 400 times divergent and millions upon millions of miles away. To abandon your senses and everyday experience in favor of such unfounded science fiction fantasies is a fallacy of appeal to authority so extreme that it leaves the brainwashed believer impotent to trust his own natural instincts and forever thereafter chained to the fantastical explanations of astronomical charlatans. In the flat Earth model, the sun and moon luminaries revolve around the Earth once every 24 hours for the sun, and approximately 25 hours for the moon, illuminating like spotlights the areas over which they pass. The sun's annual journey from tropic to tropic, solstice to solstice, is what determines the length and character of days, nights, and seasons. This is why equatorial regions experience almost year-round summer and heat, while higher latitudes north and especially south experience more distinct seasons with harsh winters. The heliocentric model claims seasons change based on the ball Earth's alleged axial tilt and elliptical orbit around the sun. Their flawed current model even places us closest to the sun, 91,400,000 miles, in January, when it is actually winter, and farthest from the sun, 94,500,000 miles, in July, when it's actually summer throughout much of the Earth. They say due to the ball Earth's tilt, different places receive different amounts of direct sunlight, and that is what produces the seasonal and temperature changes. This makes little sense, however, because if the sun's heat travels over 90 million miles to reach the ball Earth, how could a slight tilt, a mere few thousand miles maximum, negate the sun's 90 million mile journey, giving us simultaneous tropical summers and Antarctic winters? Thomas Winship said, "The Earth is a stretched-out structure which diverges from the central north in all directions towards the south. The equator, being midway between the north center and the southern circumference, divides the course of the sun into north and south declination. The longest circle around the world which the sun makes is when it has reached its greatest southern declination. Gradually going northwards, the circle is contracted. In about 3 months after the southern extremity of its path has been reached, the sun makes a circle around the equator. Still pursuing a northerly course as it goes round and above the world, in another 3 months the greatest northern declination is reached, when the sun again begins to go towards the south. In north latitudes, when the sun is going north, it rises earlier each day, is higher at noon, and sets later, while in southern latitudes at the same time, the sun as a matter of course rises later, reaches a lesser altitude at noon, and sets earlier. In northern latitudes, during the southern summer, say from September to December, the sun rises later each day, is lower at noon, and sets earlier, while in the south he rises earlier, reaches a higher altitude at noon, and sets later each day. This movement round the Earth daily is the cause of the alternations of day and night, while his northerly and southerly courses produce the seasons. When the sun is south of the equator, it is summer in the south and winter in the north, and vice versa. The fact of the alternation of the seasons flatly contradicts the Newtonian delusion that the Earth revolves in an orbit round the sun. It is said that summer is caused by the Earth being nearest the sun, and winter by its being farthest from the sun. But if the reader will follow the argument in any textbook, he will see that according to the theory, when the Earth is nearest the sun, there must be summer in both northern and southern latitudes, and in like manner, when it is farthest from the sun, it must be winter all over the Earth at the same time, because the whole of the globe Earth would then be farthest from the sun. In short, it is impossible to account for the recurrence of seasons on the assumption that the Earth is globular and that it revolves in an orbit around the sun." Gabrielle Henriette said, "The essential feature of the year is its division into 2 equal periods of 6 months, based first on the predominating length of the days over that of the nights, and vice versa, conditions which are governed by the varying hours of sunrise and sunset, and secondly, by the either high or low height reached by the sun in the heavens at midday. The first cycle, during which the days are longer than the nights, and the sun reaches its culminating point of the year, extends from the spring equinox to the autumn equinox, i.e. March 21st to September 22nd, and the second cycle, during which, inversely, the duration of the nights exceeds that of the days, and the sun descends to its lowest point of the year, extends from the autumn equinox to the spring equinox, i.e. September 23rd to March 20th. These 2 6-month periods are also characterized by an opposition of temperature. During the first cycle, which corresponds to spring and summer, the heat gradually rises and falls, while during the second cycle, which comprises autumn and winter, it is the intensity of the cold which progressively increases and decreases. If the Earth were truly a globe, the Arctic and Antarctic polar regions and areas of comparable latitude north and south of the equator should share similar conditions and characteristics such as comparable temperatures, seasonal changes, length of daylight, plant and animal life. In reality, however, the Arctic and Antarctic regions and areas of comparable latitude north and south of the equator differ greatly in many ways. Thomas Winship says, "If the Earth be the globe of popular belief, the same amount of heat and cold, summer and winter, should be experienced at the same latitudes north and south of the equator. The same number of plants and animals would be found, and the same general conditions exist. That the very opposite is the case disproves the globular assumption. The great contrasts between places at the same latitudes north and south of the equator is a strong argument against the received doctrine of the rotundity of the Earth. Antarctica is by far the coldest place on Earth, with an average annual temperature of approximately -57 degrees Fahrenheit and a record low of 135.8. The average annual temperature at the North Pole, however, is a comparatively warm 4 degrees. Throughout the year, temperatures in the Antarctic vary less than half the amount at comparable Arctic latitudes. The northern Arctic region enjoys moderately warm summers and manageable winters, whereas the southern Antarctic region never even warms enough to melt the perpetual snow and ice." Thomas Winship wrote, "This uniformity of temperature partly accounts for the great accumulation of ice which is formed, not on account of the great severity of the winter, but because there is practically no summer to melt it. In the Antarctic there is eternal winter, and snow never melts. As far north as a man has traveled, he has found reindeer and hare basking in the sun, and country brilliant with rich flora. Within the Antarctic circle, no plant is to be found. The island of Kerguelen at 49 degrees southern latitude has only 18 species of native plants that can survive its hostile climate. Compare this with the island of Iceland at 65 degrees northern latitude. 16 degrees further north of the equator than Kerguelen is south, yet Iceland is home to 870 species of native plants. On the Isle of Georgia, just 54 degrees southern latitude, the same latitude as Canada or England in the north, where dense forests of various tall trees abound, the infamous Captain Cook wrote that he was unable to find a single shrub large enough to make a toothpick. Cook wrote, "Not a tree was to be seen. The lands which lie to the south are doomed by nature to perpetual frigidness, never to feel the warmth of the sun's rays, whose horrible and savage aspect I have not words to describe. Even marine life is sparse in certain tracts of vast extent, and the sea-bird is seldom observed flying over such lonely wastes. The contrasts between the limits of organic life in Arctic and Antarctic zones is very remarkable and significant. Vegetables and land animals are found at nearly 80 degrees in the north, while from the parallel of 58 degrees in the south, the lichen and such-like plants only clothe the rocks, and seabirds and the cetaceous tribes alone are seen upon the desolate beaches. In the Arctic there are 4 clearly distinguished seasons, warm summers, and an abundance of plant and animal life, none of which can be said of the Antarctic. The Eskimo live as far north as the 79th parallel, whereas in the south no native man is found higher than the 56th. W.N.R. Chambers, in Arctic Explorations, wrote, "Beyond the 70th degree of southern latitude, not a tree meets the eye. Wearied with the white waste of snow, forests, woods, even shrubs have disappeared, and given place to a few lichens and creeping woody plants, which scantily clothe the indurated soil. Still, in the farthest north, nature claims her birthright of beauty, and in the brief and rapid summer she brings forth numerous flowers and grasses to bloom for a few days, to be again blasted by the swiftly recurring winter. The rapid fervor of an Arctic summer had already, June 1st, converted the snowy waste into luxuriant pasture ground, rich in flowers and grass, with almost the same lively appearance as that of an English meadow." In New Zealand, situated at 42 degrees southern latitude, on the winter solstice the sun rises at 4:31 a.m. and sets at 7:29 p.m., making the longest day of the year 14 hours and 58 minutes. On the summer solstice, the New Zealand sun rises at 7:29 a.m. and sets at 4:31 p.m., making the shortest day 9 hours and 2 minutes long. Meanwhile, in England, a full 10 degrees farther north of the equator than New Zealand lies south, the longest day is 16 hours and 34 minutes, the shortest day 7 hours and 45 minutes. Therefore, the longest day in New Zealand is 1 hour and 36 minutes shorter than the longest day in England, and the shortest day in New Zealand is 1 hour and 17 minutes longer than the shortest day in England. William Swainson, an Englishman who emigrated and became Attorney General of New Zealand in the mid-19th century, lived in both countries for decades and wrote of their differences, stating, "The range of temperature is limited, there being no excess of either heat or cold. Compared with the climate of England, the summer of New Zealand is but very little warmer, though considerably longer. Even in summer, people here have no notion of going without fires in the evening. But then, though the days are very warm and sunny, the nights are always cold. For 7 months last summer, we had not one day that the sun did not shine as brilliantly as it does in England in the finest day in June, and though it has more power here, the heat is not nearly so oppressive. But then there is not the twilight which you get in England. Here it is light till about 8 o'clock, then in a few minutes it becomes too dark to see anything, and the change comes over in almost no time. The seasons are the reverse of those in England. Spring commences in September, summer in December, autumn in April, and winter in June. The days are an hour shorter at each end of the day in summer, and an hour longer in the winter than in England."
No different, only different in your mind. You must unlearn what you have learned.
Don't you miss the big time, boy? You're no longer on the ball. I'm just sitting here watching the wheels go round and round. I really love to watch them roll. No longer riding on the merry-go-round. I just had to let it go.